Welcome to Source of Life, where we explore the critical issues affecting our water. Today, we're diving into how the growth of our cities and the transformation of natural landscapes are impacting the quality of our drinking water sources. As cities expand, we see more roads, more buildings, more impervious surfaces. This fundamentally changes how rainwater interacts with the land. Instead of soaking in, rain becomes surface runoff, picking up pollutants as it travels and eventually contaminating our rivers, lakes, and groundwater. Understanding this chain of impact is where sophisticated modeling comes in. These models help us simulate how land use changes affect water quality. Urbanization, for instance, consistently leads to higher volumes of runoff. This runoff isn't just water, it's often a cocktail of sediments, nutrients from fertilizers, heavy metals, and even pathogens. Agricultural lands also contribute, with pollutants like pesticides and excess nutrients. This degradation of source water directly translates to higher costs for drinking water treatment. Utilities must implement more complex processes to make water safe. Studies show a clear link. Even a small increase in urban or agricultural land in a watershed can raise treatment costs. For example, a 1% rise in urban land compared to forest land can increase annual variable treatment costs for surface water systems by about 0.13%. Conversely, forested areas are our natural water protectors. They filter pollutants, reduce erosion, and help recharge groundwater. Losing forests to development means losing these crucial services. So, what do these models consider? Key factors include the extent of impervious surfaces, which dictates runoff volume. Soil type and topography matter for infiltration and erosion. Vegetation cover plays a role in absorbing water and nutrients. And, importantly, how close these land uses are to our water bodies significantly influences their impact. Advanced modeling tools like SWOT, which stands for Soil and Water Assessment Tool, help simulate water flow and pollutant transport under various land use scenarios. We also rely heavily on remote sensing and GIS, Geographic Information Systems, using satellite imagery to map land use and monitor changes, providing crucial data for these models. Researchers are also working on integrated models that combine hydrological, economic, and ecosystem service assessments. This gives us a fuller picture of the trade-offs involved in land use decisions. Looking ahead, challenges remain. Climate change, with its altered precipitation patterns and extreme weather, further complicates the picture. Data scarcity in some regions can hinder modeling efforts. And, of course, the goal is to translate these complex model outputs into actionable insights for policymakers and water managers. In essence, as our world urbanizes, understanding and modeling the impacts of land use change on our water sources is not just academic, it's vital. These tools empower us to make informed decisions and implement strategies like protecting upstream forests or using low-impact development techniques in cities to safeguard our drinking water for generations to come. Thanks for tuning into Source of Life.